13.3, the fundamental theorem of line integrals, video 7, example 2. We did one example earlier, and based on the length of the previous video, I think you deserve a short video. Decide if the vector function f of xy equals x minus y vector I plus x minus 2 vector j is conservative on R2. We can use the last theorem that had all those criteria and concluded with then f is conservative to try to answer this. Most of the criteria were making sure that your domain had no problems. But I'll tell you right now that R2, the entire xy plane, is open. Every point can be captured inside of a disk that lives inside of R2. Or equivalently, it doesn't contain its boundary because it has no boundary. It's connected and there's no holes in it, so the domain has no issues. These being polynomial functions, they're going to be continuous whenever and wherever, so we don't have to worry about that. So all we have to check is the equivalency of the correct partial derivatives. Well, first, it might help to say that p is equal to x minus y and q is equal to x minus 2. I guess if you wanted to be more nitpicky, you could say p of xy equals x minus y, and the same thing for q, but at this stage of the game, that's kind of understood, it's implied. So all we have to do is take the partial with respect to y and the partial with respect to x and see if they're equal. Now, the most common mistake people make here is forgetting which partial derivatives to take. But remember, if you're conservative, then this was the gradient of something, and this was already a partial with respect to x. For mixed partials to be equal, we need to take the mixed partial. So if this was conservative, this is partial x, this is partial y, so we have to switch the variable with which we take the partial derivative with respect to. I just had a prepositional brain freeze there. But anyway, we got to take the partial with respect to y of the x component function. Now when I say x, I kind of mean I. And the partial with respect to x of the y component function. And when I say y, I really mean j. So the partial derivative with respect to y of this function is just -1. The partial with respect to x of this function is +1. These are not equal. And that implies that f is not conservative. Which means if we were going to do the line integral over a curve, we would actually have to do it the old-fashioned way. Change everything to t and get busy integrating. We could not take advantage of the fundamental theorem of line integrals. So it's nice, sort of, when the question is, are you conservative? Because if the answer is no, and you're not actually doing a line integral, the problem's over. But if the answer is yes, as you'll see in the next video, then there's more work to do. Because it's probably going to be followed with, oh, you're conservative? Well, what's your potential function?